Now we are going to discuss grouping of capacitors, and in grouping of capacitors the first combination we are going to discuss is the series combination of capacitors. Here you can see that there are three capacitors of capacitance C1, C2 and C3. They are connected in series. Okay, here you can see that this is the first capacitor, and what they have done that between 2 points, one is this and another one is this, potential capital V is a potential difference capital V is created. Okay, now because of that what happens that over this plate plus Q charge is induced, plus over this plate plus Q charge is there, and over this plate minus Q charge is induced. Similarly, over this plate of the capacitor C2 the plus Q charge, and over this minus Q charge is induced, and so on. Now you can see here that because there is only one path, okay, so that's why the charges which are induced or charges which are produced over the plates of the capacitor are same. So here the charge is constant for all the capacitors, okay, and because the capacitance is different, that's why there is difference in the potential difference across the capacitors. Across the first capacitor the potential difference is V1, across the second capacitor the potential difference is V2, across the third capacitor the potential difference is V3. Okay, so now what we can do is we can write it as, one thing is very clear that this V is divided into V1, V2 and V3. So the first expression which you can write is V is equals to V1 plus V2 plus V3. So what is divided in this is the potential, and let it is equation number 1. Now as far as the capacitance formula is concerned, you know that Q is equal to CV. Now we are talking in context of the first capacitor, so in context of the first capacitor Q is Q only because the same charge Q is only induced there, C is C1 and V is V1. So Q is equals to C1 V1. This is what the total charge Q is there over the first plate. Okay, and this implies you can write here that V1 is equals to Q upon C1. V1 is equals to Q upon C1. Similarly, you can write for the second and the third capacitors as well. V2 is equals to Q upon C2, and V3 is equals to Q upon C3. V3 is equals to Q upon C3. So these are the potentials, expression for the potentials. Okay, now what we can do is we can substitute these values there, but before this let us do one more thing. Let us consider that the resultant of the series combination of capacitors is CS. If CS is the resultant capacitance of the series combination of capacitors, then we can write it as V, the total potential, is equals to Q, total charge, because charge is same for all, same charge has flown, so V equals to Q upon CS, where V is the potential, total potential V, Q is the total charge, and CS is the resultant of the series combination of capacitors. Now these all values V1, V2, V3 and V, we can substitute in equation number 1. Let us substitute in equation number 1. If you substitute all these values, what you are going to get is, let us see what you are going to get here. When we substitute it, you will be getting, in place of V, it is Q upon CS is equals to Q upon C1 plus Q upon C2 plus Q upon C3. You can see here that Q is common in all. So what you can do, you can take Q common. This is Q into 1 upon CS is equals to Q common 1 upon C1 plus 1 upon C2 plus 1 upon C3. This Q is cancelled. So what is left is 1 upon CS is equal to 1 upon Cs is equal to 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3, and this is what the expression for series combination of capacitors. This is the resultant capacitance in the series combination of capacitors. I hope it is clear to you. Thank you.